Hi, in this video I'm going to talk about a little bit more on logarithmic functions. Again, this will be, we're still at the introductory phase to logarithms, alright? Feel free to rewind in any part of the videos and let's get started. So, let's say today, in the previous video, we came across this example, 2 to the power of 3 is equal to 8. Okay, and if I write this to logarithmic form, I will have log, the base is 2, right? Log, and then we know that logarithmic functions, they will always give us the power or the exponent, and right now my exponent is 3, so the 3 goes there, and the 8 is just the 8 goes there, right? So let's take a look at another example. Let's say today, if I have 3 to the power of 4 is equal to, so 3, that'll be 81, right? So if I convert this to log form, I'll take log, my base is 3, right? My base is 3. And again, I will always get an exponent from my log. So the exponent is 4 now, and 81 just go there. All right, so a general form would be, so if I have a to the power of x is equal to b, right? The general form would be log. Now the base is a, right? So the base is a, and again, log always gives us exponent, which is my x, and then my b just go there, right? When we talk about the exponential functions, we mentioned that my a has to be a positive value. It has to be positive, and then it cannot be 1. Right? So same thing here. Your a over here, it has to be positive, and it cannot be 1. All right. So just keep that in mind. Okay. All right. So let's look at a few examples. Let's say today they want us to evaluate log 125 to the base of 5. All right, so because we're not very familiar with log operations, but what we can do is we can convert this to exponential, right? We can convert this to exponential. So I'm going to say, okay, let's say log 125 to the base of 5 is equal to my x, right? Which means, remember that log always gives us the exponent, right? So right now my base, this is log 125 to the base of 5, so my base is 5. And right now it says my x is my exponent, so 5 to the power of x is equal to 125. Right, so 125 is equal to 5 times 5 times 5, so this is 5 cubed. So 5 to the power of x is equal to 5 cubed, then obviously my x is equal to 3. Okay, or let's look at another one, but this might be a bit more a bit harder, a bit more challenging. So if I have log 64, log 4 to the base of 64, and now that looks pretty awkward, right? So let's say this is equal to my y. So I don't know what it is, but I'm just gonna say, okay, that's equal to my y. And let's try to convert that to exponential, right? Convert this to exponential. So the base is 64, and when I carry out a log operation, I always get the exponent, right? So 64 to the power of y is equal to 4. Now 64 is equal to how much? Let's say divide this by 2. They'll get 32. I give out 2 again. I will get 16, 2, 8, 2, 4. All right, so I get 1, 2, 3, 4, 5, 6, and this is equal to that's a 4, that's a 4, that's a 4, right? Because the reason why that I'm not using a 2, I'm using a 4 here is because I have a 4 there. Does that make sense? So this 64, I can write that in terms of 4 to the power of 3. The whole thing to the power of y is equal to 4. I can put down a power of 1. It doesn't hurt. Okay. So I have 4 to the power of exponent to power to the power. So I'm going to multiply them. So 4 to the power of 3y is equal to 4 to the power of 1. So my 3y is equal to 1. Right? My 3y is equal to 1. So my y is equal to 1/3. This part, that is just simple division, right? Just division. But after we have divided, and why did I divide by 2? Is because we're always trying to divide, when we're carrying out this divisions, we are trying to use prime numbers, so 2s and 3s and 5s and 7s, right? And then from what we get here, we try to put them up in, right now we're using 4 because I have a 4 there. Right? So if the bases are the same, then it will be easier for me to solve it using, if the bases are the same, then it'll be easier for us to solve the exponent. Right, so my y is equal to 1/3. Okay? Alright, so that's it. Try out the exercises, practice a little bit more, and then you guys will be alright. Now, I would like to continue this video by going over a few properties. Alright? So there are a few properties for logarithmic functions. So the first one is this. Log a to the base of a, right? Log a to the base of a, what is this going to be equal to? So if you think about this, say log 3 to the base of 3, what is this? Right, so if you're not sure, go ahead, give yourself a variable. Let's say this is my u. Let's say u, right? So I can convert this to exponential. I'll have 3 to the power of u is equal to 3, right? 3 to the power of u, 3, u, and that 3 goes there. Okay? So what's my u? My u is equal to 1. Right? And that makes sense. Right? Because 3 to the power of 1 gives us 3. So log a to the base of a, that will always give us 1. Right? That will always give us 1. Now the next one. Log 1 to the base of a. Okay, so let's try to give ourselves another example. So instead of log 3 to the base of 3, I'm going to use log 1 to the base of 3, and let's see what happens. Right? And let's see what happens. So if I have log 1 to the base of 3, then let's say that value is equal to u, and let's convert this to exponential. I'll have 3 to the power of u is equal to 1. Now, 3 to the power of what gives us 1? Think about it. 3 to the power of what number gives us 1? I hope your answer is 0. Right? Anything to the power of 0 is always 1. And if you want to know how, or why is that true, come see me. Come and see me. Alright? So, let's go back to this property. The log 1 to the base of a. Right? It doesn't matter what your base is, but your a has to, remember that your a must be positive, right? Your a must be positive, and your a cannot be 1. All right, keep that in mind. Sorry. Oh man. Okay, so log 1 to the base of a, it will be 0. Okay. Now, what about this? What about this one? So log 0 to the base of a, what is that equal to? So let's give ourselves an example. So here, instead of 1, I'm gonna have log 0 to the base of 3 is equal to u, right? And we're trying to find u. So if I convert this to exponential form, I get 3 to the power of u is equal to 0. All right, here's my challenge for you. Is it possible for me to find 3 to the power of something that will give us 0? I have a positive base to the power of something. You might say 3 to the power of half. Well, 3 to the power of half is square root 3, which is approximately what, 1.3 1.73 something, right? 73, so which is not 0, right? What about 3 to the power of 1/3? Well, if you put that in your calculator, you will get 1.444 something, right? So even a fractional exponent, that doesn't give me anything that's negative. Sorry, not anything that's 0, right? Because this is not possible. This is simply not possible. If you think about it, how does the graph look like? This is exponential graph, right? My y is equal to 3 to the power of u, right? 3 to the power of u. So in this case, my graph will look like that. And remember, we always have this horizontal asymptote, right? I have a horizontal asymptote there. So of course, this y will never be 0, right? Y will never be 0 because of the horizontal asymptote. Does that make sense? Okay, so let's come back to the property. Log 0 to the base of a. That is undefined. Okay, that is undefined. Just as my u is undefined over here as well, because I cannot find any value. All right, there's no such thing. All right. Okay. Now, lastly, for this video, this will be the last property that we are going to cover for logarithmic functions. Okay. Log. Now the base is the base is a again. Log a to the power of n to the base of a. Now what is this? Right? What is this? So let's give ourselves another example. So I'm going to erase all this. If you want to go over this, what I just discussed just now, feel free to rewind the video. Okay. So now I have 3 to the log 3, and let's say this is 3 to the power of 2, right? I'm just giving myself a few examples, and let's say this is my w, right? So now I'm just going to convert this log form into exponential form. So I have 3, my base is 3, right? This is my base, my w is my exponent, right? So I'm going to let me erase that, and then this is equal to 3 squared, right? 3 squared, because that part goes there, right? And now what's my w? Obviously my w is equal to 2, right? Obviously my w is 2, right? So log an to the power to the base of a, that will be n, right? Whatever I have over there, isn't that my w? Right? So this is the last property that I'm gonna show you guys in this video. Feel free to unwind and make sure you remember them. All right. Well, throughout the videos, I have explained to you guys why is it 0, right? Why is it 0? Why is it 1? Why is it undefined? And why is it n? Right. So now, even though I'm asking you guys to remember these properties, you need to understand why. Okay, you need to understand how did these properties come by. And once you understand why, you will be good. It will be a lot easier to remember. Okay, I'll see you guys in the next video. Bye-bye.